So welcome everyone. Thank you for coming here to the Reunión Internacional de Inteligencia Artificial y sus Aplicaciones, or RIA in short for Spanish. This is the human-centered AI panel, and I'm delighted to welcome Stevie Chancellor, Gonzalo Ramos, Bryan, Pardo, and Irene Alvarado to this panel, talking about how we can develop AI and machine learning techniques within the context of what humans really want and need. Here also in the chat is going to be Luba. She's going to be our chat moderator. She will be taking in all of your questions that you put in the chat, and then we can discuss them later at the Q&A. Without further ado, I'll introduce our first speaker, Bryan Pardo, who is a tenured professor at Northwestern University. He heads the Interactive Audio Lab, which develops new methods in machine learning, signal processing, and human-computer interaction to make new tools for understanding and manipulating sound. In addition to his extensive career in research and numerous publications, he is also a professional musician and a great swing dancer. So without any further ado, Bryan, take it away.
Wow, okay, thank you. I am going to share my screen so we can talk. So before I became an AI researcher, I was a musician, so a lot of my thinking is for how to make musicians' lives better. And I went onto Google and I Googled for musician, and this on the left was the top picture I found from Google. And then I Googled recording.
I don't think we can see your screen, Bryan.
You can't see the screen? How about now? Okay, well, let's do this another way. So the deal here is that musicians and engineers are not the same people, okay? And I bet I can share a Chrome tab because I saw that work. So let's share a Chrome tab and let's look at something. We'll come back to this. If I Google for Pro Tools right now, can you all see, am I Googling? Can you see that? If you nod, I can't see you. I am only seeing my screen for the tab. So okay, great. And let me just, call up something here. Let's make this big. Or, let's make it really slow. That's the other thing we could make it. Okay. This is a picture of, this is a picture of Pro Tools. This is the most commonly used app for mixing and mastering albums. And right now on the screen, there is a tool that if I were to say, the sound is too, say, agudo, or too sharp, too tinny, I could use this tool to fix the sound and make it better. The problem is there's nothing on this interface that is a knob that says something like tinny on it. So there's this translation problem. There's a sound in my head or a sound in the world that I hear. There's a sound in my head I want to get to. And there's this tool that I have to translate my ideas through. And if you are in this RIAA conference, then if you are in this RIAA conference, you probably speak 2 languages, most of you, or have at least tried to. And translation is hard. It takes a long time to learn, whether you're learning English to Spanish or learning human to Pro Tools. And so one of the things that we think about is we want to change the way the world works. Instead of forcing humans, musicians, artists, to learn the mindset and the names of all the controls and what they do. So like you learn the machine, could we have the machine learn you so that you could tell the machine in words what you want? or show the machine with an example what you want, and then the machine would do what you want. So an example of this, we're going to try and screen share again, and I hope this works. Right. We'll go back to this, but now we're going to go to an example app. So this is Audialize, and we crowdsourced audio production. So normally, if you try and change the way a sound works with an equalizer or a reverberator, that equalizers change sound. Normally, these are tools used to control audio, to control how it sounds and make it sound better when you're recording an album. So here's let's say that my guitar is not dark enough, not low frequency enough. I have to come down to this thing and start. This is the old school interface. Okay, it's going to take me forever. Or what if I had done a learning interaction with other people before? What if my machine had done a learning interaction with hundreds or thousands of other people, presenting them different equalization settings and learning from them which words they use to describe them? Then I could just use my words and say dark, and I would get the equalization curve that makes it darker. Or if I wanted it to be, I don't know, crisp. And these words, I'm going to stop the audio. These words were learned, like crisp was learned from 16 people who associated this EQ curve with crisp. Or what if I did it in Spanish? And I'll say for a moment, profundo en vez de oscuro. And the reason I'm saying that is because you might think, oh, maybe in one language, like the same word dark might be used to mean the same thing. And sometimes it is, and sometimes other words that we don't expect are the descriptive term used in another language. But you could make machines that learn the descriptive terms in whatever language and give you these controls over things like equalization or reverberation. Here's another one. I want to sound like I'm underwater. And you can sort of imagine what that might be. And 100 people thought this was underwater. And I'll stop with the demo there and just say that this is one example of a lot of things we're doing. Let me come back to a lot of things we're doing to try and rethink user interfaces for artistic control of, for in this case, recording production tools, so that somebody who thinks like an artist as opposed to who thinks like an engineer can communicate to the tool in a way where they don't have to spend 6 months learning the tool. They just think, well, how would I describe what I want to do? And then it does it. And so I'm at 10 minutes. So I'll just stop there and say that's our design philosophy, and we're using machine learning to make that happen. Thank you.
Thank you very much, Bryan. That was a great demo. Up next, we have Stevie Chancellor. Stevie is a postdoctoral fellow at Northwestern University who explores how to conduct human-centered machine learning with a focus on online communities and mental health. She has been recognized for her work by numerous awards and fellowships, and in 2021, she will begin her new position as an assistant professor at the University of Minnesota's Department of Computer Science and Engineering. So take it away, Stevie.
Thank you, Andong. Let me also do the screen sharing dance as well. Get this set up. Excellent. It says that I'm not allowed to share my screen right now.
Oh, okay.
It is giving me like an X mark over it.
Yeah, there might be an issue. Let me just change the settings a little bit.
Sure. And if this doesn't work, I can always just talk for about 10 minutes or so.
Okay, yeah, I think, just give me a sec. Can you try now?
Let's see. No, it's still saying no. We will just, why don't I just talk for about 10 minutes and we'll call it good.
Okay, thank you. Sorry about that.
No worries. I don't have any important photos or things to show. So hi, I'm Stevie. I'm in computer science at Northwestern, and I do research in human-centered machine learning for mental illness and social media data. So today I'm going to talk to you about some of the lessons that I've learned throughout working on this domain and this topic for about 7 years at this point. And I'm really excited to talk to you kind of about some conceptual ideas that I've been thinking about and working with experts and working on problem domains where there aren't actually clear answers of how to solve them. So quick fair warning, I'm going to be talking a little bit today about high-risk mental illness behaviors. In particular, I'm going to be talking about suicide prevention. So I said I've been working on this for about 7 years. And in the last 7 years, research has come a long way in being able to use text, behavioral, and other cues from social media data to predict mental illness. This includes disorders you probably have heard of, like depression, anxiety, and suicidality, as well as symptoms and other signs that come along with mental illness, like stress or cognitive dissonance. We're finally seeing adoption of these technologies into industry practice and today. So Facebook in particular has built a suicide prediction system on its backend that looks at your prediction system, or that looks at the data that you pass through Facebook, including messages, posts, and other behavioral cues to predict if you're at risk of harming yourself. So today I want to talk about some of the lessons that I've been thinking about in this space and how it might apply to other human-centered machine learning approaches. And I'm framing this as a little bit more conceptual rather than kind of walking through my work, because I think that it'll be fun for the other panelists to talk about maybe later how their work kind of embodies some of these questions and these problems and challenges in working in tricky domains, whether it be audio or mental illness. So as I mentioned, Facebook has a system behind the scenes that can predict about, it says with high accuracy, not sure how high that is, but it finds about 3,600 people a year that are otherwise not reported to the platform that may be at risk of taking their own life. Now, Facebook said in, I believe, March of 2019 that they were getting these people without other people recommending or reporting them to the platform at being at risk of harming themselves. So Facebook isn't the only one that has this kind of system on the back end. Other social networks and online systems have it as well. And some governments have started adopting these systems on the back end to surveil citizens and deploy interventions when they're important. So I think that this process of generating these prediction systems has a lot of pieces that come along with it. And if we think of this from Facebook's perspective, there's not only the technical and engineering side of things, of being able to design features that accurately capture suicidality, the right architecture to represent these thoughts. Are they comorbid, and do we need mixed representations within architectures to understand image data, text, behavioral cues, and other signals? But there's also other challenges that pop up in this domain too, right? There's the issue of concept drift over time. Do people start reacting to the algorithm and talking about their injuries or their feelings differently in response to being surveilled by the platform? Maybe there's also issues of bias, of what kinds of expressions are captured by platforms. And maybe we're biasing because of the dominance of Facebook's engineering team to English or Western representations of what it means to struggle. Now, moving beyond the technical side, though, I think that there's also a lot of important socio-technical things that come along with this problem as well, right? Facebook deciding to build a system that predicts whether someone may be thinking of harming themselves has a lot of interesting implications for Facebook on the back end. Who on Facebook's team has to deal with this and make the decision of what level of intervention is appropriate? Do you lock someone out of their Facebook account, or do you send the police because you believe that there's an urgent and imminent threat, perhaps to themselves or to others? And I think that this kind of a problem space highlights not only the technical challenges that come with human-centered AI, but also the socio-technical challenges of not only addressing needs for people, but also needs of Facebook, and kind of fundamental questions about whether or not the predictions that we are building through systems like Facebook's or someone else's are fundamentally useful, ethical, and helpful to people in these communities. And so today I want to talk a little bit about how there's like three kind of priorities that I've noticed in thinking about the suicide prevention example and some of my other work, which focuses on self-harm, opioid use disorder, and eating disorder communities. And the first is that in this space, I think it's really important to prioritize things like collaborators, right? Not only in thinking about collaborating and working with Facebook, but if Facebook is considering deploying a system like this, their collaborators should align with their interests. You know, they probably need doctors and they need a suicide prevention association. It's crucial to have good collaborators that can hone in on the contributions of the project in the right domain. And for me and my work, that's often doctors, it's medical professionals, sometimes it's community moderators that work on suicide crisis forums or other communities. But for other topics, that domain expertise is going to change, right? For hate speech detection, perhaps that's lawyers, experts on race and gender, and activists. But the other thing that I noticed, and this is a reason it becomes a tension, is collaboration's really, really tricky. And managing different disciplines and contributions is incredibly challenging. And trying to submit to different venues and have people understand and be able to communicate about the problems themselves, what's robust in machine learning and in clinical psychology may not actually align with each other. And so when we use terms like robustness, those may come into conflict in different fields. And so working with collaborators oftentimes can be a multi-step and kind of, I want to say complex, but it can be a complicated process in navigating people's interests and making sure that you're bringing concepts in from both sides of the domains you're working in a way that accurately represents what both sides care about. Now, I've talked a lot about like working with collaborators, right? But I've also mentioned other people in Facebook's system that are really important stakeholders. So there are other stakeholders that have to be considered as well. And their opinions also really matter in deploying a human-centered system. So the stakeholders in the spaces that I work in are people like the users of Facebook, who may not necessarily be aware that Facebook on the back end has a system that's predicting whether or not they may be at risk of harming themselves. And people at different stages of their mental illness, whether it's severe or mild, or perhaps those who don't struggle with suicidal thoughts, may have different opinions on what this should be. But there's also formally trained experts, law enforcement, and friends and family of affected people that are really important to prioritize when building out these systems. And learning to account for stakeholder values is also really, really important. And the last thing that I think that comes up with the suicide prevention example that's important for all HCAI systems is about the values that we embody within systems. So in addition to designing for technical impacts, I mentioned the socio-technical realities of systems as well. The questions that we build into these systems are driven by other values that we may have, like health or trustworthiness, safety, personalization, and interactiveness. And I want to highlight these values as not only is not competing with the technical impacts, and many of us sort of think about these problems that way, but that it raises important questions about how we make decisions within our research and our understanding. So that's all that I have, and I'm really excited to chat with you guys more about your research and how we can think through some of these questions with your work. Thank you.
Thank you very much, Stevie. Just, I guess, as a heads up about the technical issues, I think it was only allowed for 5 people to share their screen, and like to share their video, and we count, like a screen share counts as one of those people. So I think what we'll do is I'll present the speaker, and then I'll kind of step out so you guys can share your screen, and then I'll come back in once this screen sharing is done. But thank you. The next speaker is Gonzalo Ramos. He is a principal researcher at Microsoft's Grounded Reasoning and Interactive Learning Lab. His main research area is in human information interaction, where he works on interactive machine learning and teaching, as well as human-centered machine learning. And he's also quite passionate about increasing opportunities in computing, serving as a program chair for fellowships at Microsoft. So without any further ado, Gonzalo, take it away.
Audio video. Okay, can you guys see my slides? Fantastic. So thank you again for being. I'm going to give you a brief introduction, a lot of topics, but I wanted to thank all the people and teams I worked with over the past 3.5 years on these issues. Let's take it. So, in short, let's do a jam-packed presentation, but if anything else fails, I want to talk about 3 main topics. There's this idea of interactive machine teaching. It's a promising perspective on the traditional idea of interactive machine learning for a number of reasons that I can go into detail later. That in the context of this interactive machine teaching approach, the teaching languages we use to define these experiences are crucial and key. And third, that our job as human-centered machine learning practitioners is to shape these experiences. We're not victims of the technology. We actually had an opportunity to define what the experiences look like, but it's also an interdisciplinary task, so it takes a village. So why are we here? In short, what I often says is that we're in the business of creating functions. We want machines to execute programs or run these functions. And sometimes these functions are easy to specify. We know exactly the algorithm we want the machines to execute, so we provide those instructions. But many times we're just not aware of what is the algorithm for these functions. So what do we do then? Well, before we go there, a great number of functions that fall into this category are just those functions that we deem as having intelligent behavior. So we know how to do it as humans, or at least we know how to do it, but we have trouble expressing how that we're doing it. So we get creative. In order to create these functions, we outsource the task of writing these programs to systems that hopefully learn from a lot of examples that can generate this. So with this perspective of what machine learning is, I can start talking a little bit about what interactive machine teaching is. So, sure, machine learning is awesome, but it's complicated to interact with. And there's a lot of challenges to do that. Among those, and the ones I'm going to focus is the high barrier of entry that one has with trying to interact with or wield machine learning as a tool, as a mechanism, as a domain to help you. So human-computer interaction has looked into this topic of making it easy to build machine learning models for everybody. And in particular, it has worked on what has been known as the field of interactive machine learning that targets a lot of these challenges of barrier of entry. In particular, what defines interactive machine learning field is that the presence of a human in the loop that frequently updates the state of the model, reacts to those state changes, and then helps to evolve this model itself. This is in contrast to what I call machine lecturing, which is imagine providing 1 million labels to a learner system, and then you expect the learner will learn, and then it provides the output. This is a more closed, tight feedback loop. So in this diagram that I wanted to pay special attention, you can see that the human in the loop is interacting with both the data and also with the model. And think about for a moment, what are the skills that are needed to interact with these kinds of objects? So I call this roles and goals. So just to name a few. So a person has to be responsible for selecting examples and labeling things, has to choose what is the appropriate testing set. He has to perhaps engage in a feature engineering process to decide what are the right features for the model to consider. Sometimes he has to select the proper learning algorithm and then parameterize it so that it creates a good result, and so and so and so. So while it may be fine to expect this roles and goals from a machine learning or data scientist, I think it's a tall order to fill for just normal people, but no, for people that don't have a degree in machine learning or data science. So our focus is that is to attack this issue of barrier of entry and need for people that don't have the skills of machine learning to be able to use machine learning. So what we do instead is we propose and we leverage these ideas that we saw before to talk about interactive machine teaching. That emerges from the desire that we have to make it easy for anybody to create machine learning models. And we do that by scoping what we pretend we want someone needs to know in order to engage in this interactive process. So we say that it is an interactive machine learning process where the role that someone takes is that of a teacher. And that is very specific, as the next diagram will explain. So here you see an opinionated version of the diagram that we saw before, where it's very clear about the human is interacting with the learner, but not with the model. And the way it interacts with the data is by selecting what it knows is appropriate or not. So the teacher, as with normal teaching from humans to human, is responsible for picking curriculum, choosing the right examples, articulating knowledge to the learner, and then reviewing the state of the learner at the model itself so that it can adjust again this curriculum and again produce more or different knowledge that is needed to advance the process. So you may have some questions about what you see here. So what does the curriculum look like? What is knowledge? How does one articulate it? How does one review things, etc.? And many of these answers, again, I say, are for us to design. We just don't satisfy with what technology gives us. But to answer some of these questions, I want to revisit a couple of fundamental concepts circa 1986 from Don Norman that talks about the gulf of execution and evaluation. The idea is that these concepts describe in precise terms what is the effort that takes for me to articulate my goals into a system that will satisfy those for me, and the effort it takes for me to understand the system's feedback once it reacts to that specification of my goals. So a lot to talk about here, but I'll try to be expedited because of time. So I say that during the teaching loop, there's both a human and machine agencies at play because they're in a loop. And these are expressed through a language. So there's an opportunity for us to design an interactive machine teaching experience from a human-centered design perspective. And that means a thoughtful selection of the teaching language we decide to use in this experience. So there's some meaningful questions to answer, and we'll try to do those in the remaining minutes that we have. So what should the language that we use in this interactive loop be about? What are the topics that should help you communicate? What does the structure of the language look like? And then again, once you implement it, is it easy for people to use and it's easy to articulate? So in order to answer some of these questions, I'm going to share the results of some studies we did last year in the matter. So in these studies, we observed people interact with one or two simulated learners using a Wizard of Oz technology, a methodology, where people were free to express any knowledge they thought it was important for the learner to know, and in any manner they thought it was appropriate. And now we see the analog artifacts we gave people to express their knowledge. And during the studies, the Wizard modulated the interactions by simulating the learning and the feedback the system provided. And again, through these observations, we're able to, again, attack some of these questions we had, what the language should look like, what should be about, is it easy to articulate or not. So things we observe in terms of what the language should be about. So concepts, and there are many types of concepts that people wanted to express that had to do with the actual meaning of things that they wanted to talk about, but also about the structure of the media that they were dealing with. Relationships, which is how these concepts connect to each other and help sense-making in a way. And just mention one more briefly, people thought in terms of rules as well, as if they were trying to explain algorithmically how the model should behave. So it doesn't matter what we present to people. People will form theories about how the learner works. And that is an extremely interesting result that has important consequences for us designing the systems. Also, I think we observe is that and I cannot see Andong, so hopefully I'm okay for time. Give it almost done. So things we observe is that through the process of teaching, things match really closely to something that is called the sense-making loop as defined by Trolley and Card. And that identifies design opportunities for us to make the experience better and close the gap of execution and evaluation. Now, I just mention a couple of points that I think are interesting. Again, as I mentioned, mental models are important things to encourage, and bad mental models that people may form are important to discourage. We need to support what is known as concept evolution. People change their mind about the concepts and how they are defined to the learner system. People need support about sampling engineering. This is picking the right examples to show and support the ability to foresight what is needed from the system. And I can go into more detail about that in the Q&A. And then something that is about common ground, which is the language that I use to teach to the learner, should be similar or overlap as much as possible to the language the learner uses to communicate back to me. So we went a bit more further than just creating bullet lists, and we just try to build systems that implement some of these ideas. So here you see an example of the system to teach a model how to segment. And here I'm going to briefly mention that we have an area where you can see a language and the structure and the concepts it deals with. Here in the lower left, we see a moment of awareness where people can investigate the state of the model. Here on the lower right, we see an area for sampling engineering where the model assists the human into looking at the right things that should be presented as next example. So here on the top right, you see a moment of shared language where I can mark elements that are important to me, but I can also see predictions that the system does, and they're both expressed in the same language of bounding boxes. Here, there's a very brief, I'll mention the same sort of idea, but for text. But I will just glance through this one because I think I'm running out of time. So in short, hopefully I was able to tease you into pique your interest about this new concept of interactive machine teaching. This is a promising perspective on interactive machine learning that by design, because of this loop, engenders languages that are models that are semantic, i.e. explainable by design, and because of that, easy to maintain and to share. Because also, I wanted to let you know that teaching languages is so important in defining these new human-centered design teaching experiences, and that we are in the driving seat. It's our job to define these languages and what they do, and make sure that they support humans and their capabilities. And lastly, yeah, I think I merged the second and third bullets at once. And with that, I wanted to thank you for your attention, and I'll be happy to take questions at the end of the presentation.
All right, let me see if I can share my screen.
Great. Thank you very much, Gonzalo. And last but not least, it'll be Irene Alvarado, who is a UX engineer and creative technologist at Google Creative Lab. Irene works at the intersection of design and computation using a combination of design thinking and technical expertise to explore how emerging technologies will shape new products and creative tools. She also serves as an adjunct professor for the Interactive Telecommunications program. So take it away, Irene.
All right, can you guys hear me okay? All right, great. And you can see my screen, I believe. So awesome, my name is Irene. I work at a small team at Google called the Google Creative Lab. And I'm saying something obvious here, but our team was pondering. There's a ton of machine learning in products that we use, as you all know. To not belabor the point, but to give you a few examples, products like Google Photos, it categorizes objects, people, faces, sunsets, dogs, tools like voice technology tools like the Google Home and the Google Assistant, has a ton of machine learning models, right? To convert speech to text, to do the opposite, to go from text to computer voices. It has translation models, it's jam-packed with machine learning models. And then newer apps, of course, like, I'm not sure how many people in Latin America have access to this, but there's an app called Google Lens. And what it allows you to do essentially is to search with your phone. That's the idea, right? So in this picture, we have a mobile phone and it's looking at a dog. And if you just tap it, the Google Lens will tell you the dog breed. In this case, it's a Shiba Inu. So, not a surprise. There's tons of machine learning around us, but as Gonzalo also pointed out, it's not a lot of people have a sense of what machine learning really is. I mean, in this group, I'm sure we know that it's just statistics and really good data, right? Nothing fancy, but the media still portrays machine learning and AI as sort of dark magic, right? Something that we can't understand. So despite it being everywhere, it's really hard for a non-specialist. And by non-specialist, I don't just mean my mom, who never studied something technical, but I also mean engineers who might be new to machine learning, engineers that are networking engineers or web engineers that just haven't been exposed to machine learning. So my team created this page called AI Experiments, and it's a page that shows a bunch of what we call little experiments. They're these little experiences that showcase some of the newest Google research in machine learning and make it in a way that's much more accessible. And a lot of this, we do it through creating these little games and demos that are really interactive, they're really playful, and really importantly, that anybody, practically anybody with just a web browser is able to use. That's a very important component of our sort of philosophy around accessibility. So I'm going to briefly talk about 3 projects that I think illustrate how sometimes starting with something really accessible and simple can also lead to innovation. I'm going to show how some of these projects have led to research back to the academic community, or in some cases, totally new tools for people to use. So the first project is called Teachable Machine. And this is a little screenshot of it. It's essentially a web tool that lets anybody create a classification model to categorize things in your web browser. So I'm going to actually give you a very quick demo. Can you guys see the page for the app? I believe so, right? Yeah, if I go there, you can see the Teachable Machine page, right? Okay, I'm going to assume that you can. Actually, I can probably do this. Yes, okay, I can see my screen. So very quickly, this is going to be a very quick demo, but the way it works is I'm going to create a neutral class, and I'm going to give it some examples of my face, right? So I'm collecting about 40 images of my face. I'm going to call this class, it's a second category, I'm going to call it left, and I'm going to give the computer some examples of my left hand, about 50 images of my left hand. And I'm just going to create a third category, I'm going to call it right, and I'm going to give the computer some examples of my right hand. All right, and now I'm going to train the model. So again, just to summarize, this is just a web tool. Anybody can access it in the browser. And just by having an internet connection, basically, you can use this tool to train a computer model. So right now it's training, and there's a bunch of sort of advanced settings for whether you want to get into the nitty-gritty of changing the model and how it's trained, et cetera, et cetera. But right now, let's just let it train. By the way, all of the processing is happening in your browser, so none of these images are getting sent to any servers. It's just happening, everything is happening locally on your computer. So the model is done, and here on the right, I can see that right now it's categorizing this image as neutral. I can raise my left hand, and it's sort of correctly categorizing this as my left hand. And I can try with my right, and there we go, it's correctly categorizing it as my right hand. So I can kind of go back and forth. So this is just a super quick demo. This app, we released it, and as we usually do with all of these projects, we put the code online so that anybody could use it. And we also wrote a research paper around how one could use the interface to create other machine learning tools. And something that surprised us is that a lot of people in education started using this. So actually, some folks at the MIT Media Lab, they started creating curriculum for middle school students to learn about machine learning and to be able to use this tool to learn about bias in data sets, for example. Another example is that renowned computer scientist named Hal Abelson, also at MIT, was using this really simple tool to teach policymakers about machine learning. And for a lot of these policymakers, apparently it was the first time that they were actually able to wrap their heads around what it was and the relationship between data and bias in your machine learning systems, because it was one of the first examples of something they could actually interact with and play with. So needless to say, this very silly little project at the beginning became a tool that's being used all over education. So that's the first example. The second example, very quickly, I'm also going to give a very quick demo, is a project called QuickDraw. And this is very much a game. It started as a game where you can teach a neural network how to recognize a drawing, or you're getting a neural network to recognize how you draw. So again, I'm going to give a very quick example. This is QuickDraw. I have 5 minutes. And so what's going to happen is I'm going to be drawing, and the computer is going to try to guess what my drawing is of, right? So let's just play it for 1 second. So it's asking me to draw bread. Okay, so let's try that out.
I see garden hose, or squiggle, or mustache, or mountain. I see hexagon, or eraser, or animal migration, or lightning. I see piano, or bus, or couch, or sandwich.
Okay, it's not recognizing the bread. Let's try again. Flower. All right, let's see if I can recognize a flower. I'm going to draw a...
I see matches. Oh, I know. It's flower.
Great, awesome. And then skyscraper. Let's see if I can draw this one. So I'm going to
draw... I see line or fence. Oh, I know. It's skyscraper.
All right, so I'm going to stop playing now. But QuickDraw, as you can see, the game is very simple. You just have to draw something, and a neural network is going to try to recognize what you draw. But at the time, there wasn't really a data set of this sort of thing, of people drawing things. So we open sourced a data set of about 50 million drawings. And out of that data set came all this research. So some of the research came from Google, some from out of Google, of people trying to get models to work with that data set and to learn how to draw or do generative drawings. And then out of that came a model that Google put out called SketchRNN. And it's just a recurrent neural network that can draw or that can predict drawings, which is very cool. So that's the second little example. From this like really simple game, actually, so many people played it that we were able to create a new data set that then fueled a bunch of research and created some new models. And here's one last very quick example. I don't have time to demo this one, but it's also a web experience. And the concept is really simple. You basically stand in front of your webcam and you can strike a pose, you can move. Your webcam is going to detect that pose and it's going to try to serve a matching image. So this is the same experience. You can see it being tried here, as an interactive installation, and all the pose detection is actually happening on this tiny little phone. So in order to do that, what we had to do was to actually create a whole new model, which was actually the first model for something called pose estimation, which is being able to find out where your body joints are for the web. And the reason why we did that, we had to create it from scratch, is because we wanted this to be really accessible. We wanted anybody to just be able to open a website, go to URL, and not have any kind of fancy technology. They just need a webcam in order to use this. So again, we published the code on GitHub. We wrote some articles for it, and of course, tons of people started using it, doing really fun things. Also, companies that are building products with this, companies that are using Tensorflow Js. So again, this was a project where to even make it possible, we had to create whole new libraries and technologies in order to make it happen. So that's three seemingly simple and sort of silly projects that started because we were exploring how to communicate machine learning in a more accessible way that anybody can understand. And through the process of making them, because millions of people use them and because we wanted to keep them really simple and accessible, some of these ended up contributing, data sets, models, research back into the machine learning community. So that's pretty much it. All these projects, you can find them on the AI Experiments site. And my message to you here really is that, as practitioners and researchers of machine learning, our field is pretty serious sometimes. It can be hard for newcomers to get to step into it. And don't ignore the power of play and experimentation and games and keeping things simple. That process can also push the needle for innovation. And it's done so quite a few times for my team. So that's pretty much it. Here's a summary, and I'll make sure to paste some of these links in the chat so you guys have access to them. Thank you.
Thank you so much. That was really, really great. I think for all of the speakers, the chat has been flooded with questions about where to get the GitHub demo, where to get the slides. So if you guys can share that, I think a lot of people here would appreciate it. So we're going to go ahead and go with the Q&A. And I want to start with a general question. I think the underlying theme of all of your talks has people and machines working together, which, when you say it, it sounds very intuitive, but I think as we know and what we see in the news is that it often is not portrayed that way, and often machine learning research is done independently of people. So I just want to talk a little bit about what are the dangers of having that kind of keeping humans out of the loop completely and just developing machine learning by itself, if anyone wants to start.
I'll hit that. The danger is vacation bot. Imagine there are things that we like to do and things that we don't like to do. And there's parts of the things that we like to do that annoy us. What I want machine learning to do is I don't want to be replaced on the things I like to do. If someone made, this is a ridiculous example, but if someone made a vacation bot that promised that I would never have to go on vacation again, it would go to the nice resort, it would take pictures, it would put me in the pictures, and I could work the whole time. That might not, and then they could take away vacation from me. That might not be a good thing. But there might be aspects of my vacation that I don't want to have to figure out, like, finding the absolute best. You guys remember when we used to get on airplanes? Finding the best deal on the best flight. That's a part of something that I do for my vacation that I don't want to have to spend hours on. I just have to. So I think about what are the parts of things that I want to do that slow me down, that take me out of my flow. Can we have machines learn to help me with that? And then, like what Irene was talking about, what are the things that right now maybe I can't even imagine how to do. But if a machine did this extra step, all this extra creativity would happen because, oh my God, this is possible. And then I make all sorts of wonderful new things. And so I think having the end users, whoever they are, in this tight loop dialogue with the tool builders and giving them, in Irene's case, it's a great example, access to the tools as they're being built so people can modify them and repurpose them and use them in unexpected ways. I think the best way to make sure that machine learning tools end up serving us instead of, not.
Yeah, go ahead, Gonzalo.
I have a lot of thoughts in the space, so I'll try to just maybe grab a couple of ones. A lot of people have talking about, we live in another Oppenheimer moment, and with AI, ML, and I like to often think about artificial intelligence. Its name is can lead into a dangerous direction. So why do you want to create artificial intelligence? What is the goal of making an autonomous entity that just has its own goals and aspirations? I much rather think of AI as augmented intelligence, as a way of supporting people to be better, which feels a much more human-centered goal. I think that some of the dangers that there are about not thinking about humans in the loop are present right now. If you think about, hey, let's create technology to create deepfakes because we can, but why? What are the immediate implications of that? Or let's create technology to do face profiling of people's identity from cameras on the street. What's the worst that can happen? So I think that this idea of technology possibilities driving innovation is useful, but the possible consequences of it leading to dark places is so straightforward right now that it needs to be tempered through a human-centered perspective. That's why I think it's so important that we work interdisciplinary between human-centered design practitioners, but also technologists that are embedded into the development of AI techniques.
Just a short point to complement what Gonzalo is saying. I think in many cases, I augmented intelligence. In many cases, some of the best models that have been reintroduced into use cases that matter are those where there's a tight coupling of a human using a computer. So I'm actually going to link to one such research where a company that Google has called Verily developed some machine learning to detect early onset of blindness. And the way that it's integrated is that this model sort of screens a bunch of images for the doctors to then have a second step and screen themselves and then talk to the patient. So it's not the model working on its own, and it's not the doctor working on its own. It's both the team of the model kind of cutting corners and making the doctors work faster. That is actually why the program is successful. So I think in the best cases, like, models have been not just developed with practitioners in mind, but actually introduced into the workflow of a doctor or a lawyer or an insurance agent or whoever it may be, pilot, right? So.
If I can jump in, I think of the last one. I totally want to plus one what everybody was saying. Gonzalo, I was reminded of the Jeff Goldblum quote from Jurassic Park, where it's like, you scientists didn't consider what you were actually making before you did it. And I think that there's a lot of that is true, in that sometimes we make things like deep fakes, or we make other technology that we're not actually thinking about how it can be applied. And some of that is media hype about the technologies that we're building. I think about people who see my research and they're like, oh, so you want to cut psychiatrists out of the loop, or you don't want psychologists to work with people anymore. You want it to be a chatbot. Far from it. I know my clinical collaborators are just completely overwhelmed and don't have enough bandwidth to see patients. And so if we could help assist in making systems that make parts of their job easier so they can focus on the things that they do uniquely well, 15-minute talk therapy sessions instead of collating and organizing notes or responding to emails or managing their schedules, that would be a huge boon for them. And I think it's important that those kind of goals and outlines are like stated at the beginning of projects, right? Is our goal here to like get rid of this technology because you don't enjoy using it? Or is it maybe to supplement it so you can spend more time doing other things that are more important? And that requires, I think, good communication and collaboration with people who are excited about the domain and deeply invested in the questions and goals of that space.
Great. Thank you for all of that. That's a lot of food for thought, and definitely the direction I think machine learning should head in. As we think about human-centered machine learning, I think that, you know, we also have to keep in mind that a lot of people are not in, you know, the Western world where they have, you know, a lot of Wi-Fi, really well-built browsers, and, you know, a lot of bandwidth. So one of the questions we had in the chat is actually, you know, can we develop machine learning, human-centered machine learning for people, for instance, in rural zones where they might not have a lot of data, or they might not have a lot of computing resources? Have any of you thought of these questions?
Really briefly, that I think Google's role is to create some of the foundational technologies. So Tensorflow Js, for example, is a great example of this. It runs in people's browsers locally, so you don't need to send your data to a server, right? So it could work for someone that maybe is offline, for example. It also is connected to WebAssembly, so it can work on really low latency, like really old phones that are available in some of these places. So I think like our role has been in creating foundational technologies, for microcontrollers and old phones, and we'll continue to do that.
Also, kind of like a brief answer. I think that there's a little more work that needs to happen in the area, and part of the answer is perhaps make silicon that actually is cheap, affordable, like for everybody, easy to do, that can do machine learning. But there are other ways in which I think machine learning can help people that don't have access to the technology. So this falls into a in preparation talk that I have, in which I think about machine learning as something that, as a substance that has three ways of looking at it. It can be a tool, it can be a material, or it can be a medium. So you can help people with machine learning without them having to use machine learning. You can actually help the environment that people don't have access to technology through proper planning. And in that case, you use machine learning to do that. So machine learning can help individuals, not by direct contact with machine learning, but I think that there are different stages and layers that can be helping with. And again, this is a work in progress. I love that question. I think that we need to do more to help out.
One thing that I think already got mentioned, but I'll mention it again. This is one great example of why we need to have more diversity in who is actually designing the tools and having the conversation. They've got so much evidence that like the diseases that people attend to are the ones of the people who have the money that give the grants, right? And even just something as dumb as font sizes on phones tells you a lot about the age of the people who designed the interfaces. And we need to make sure, and maybe this conference is a way to start that, to get voices from different communities actually brought into the machine learning community at places like Google and Microsoft and Northwestern. So, because as much as we who have all the fancy technology and had running water when we were growing up, think we can get in the mindset of someone who didn't, there will be things that are obvious to them that are never going to be obvious to us. And we have to find more ways to include them in the process early. That's it.
Go ahead, Stephen.
I just want, again, everything that everyone was saying, and talk about something I think that's tightly related to this concept that was brought up in about making sure the systems that we build are even functional in other contexts than just the Western world. So I do research on eating disorders, and most of the data from the sites that I work on, like Instagram and Twitter, are going to be coming from wealthy Western contexts, right? We may just be completely missing what eating disorders look like in other domains. And that's a huge challenge in claiming any sense of generalizability of this model to the real medical definition of what an eating disorder is. And I imagine this happens across a lot of contexts, whether that be disease detection or emotional detection or movement or behavior patterns. And how do we manage that as a field? Like, do we try and go get more data? How do we deal with low resource contexts and making sure the perspectives that we're bringing in are aligned with stakeholders that weren't considered sort of in the Western context in the first place? And one of the ways I think to work on that is by having broader perspectives and working with people who are directly in those communities that can tell us what's important, and bringing them along not only just as like informers or key stakeholders, but also as like equal players and collaborators within this work, and prioritizing their needs, which sometimes means maybe machine learning isn't the right solution right now because it doesn't actually serve the community and what their priorities are. And that's a little hubris, and like as a computer scientist, like I really get excited about building new things, but I think it's important to consider.
Great. Thanks, Stevie. Yeah, we definitely +1 to everything. I can't go through every single one of those, otherwise I'll like use up all the time that we have. But I think we have time for one last question, and this is, I guess, a bit selfish on my part, but as a person who's trying to get into human-centered machine learning, human-centered AI, what kind of tips or advice would you give, future researchers here in the crowd that are trying to get into this area? But it's a lot of work, because it's not just learning about machine learning and AI, it's also learning about the different domains, it's learning about human psychology and sociology. So what would you all, I guess, recommend to all of us?
I can.
Yep.
It's gonna be tough. It's gonna be tough love, because we have a short time. But I'll go with this. You need to pick a lane. Human-centered machine learning has a lot of subtopics that have to do with fairness, accountability, and transparency. It could be about explainability. It could be about interactive machine learning. So there's a lot of areas that deal with human-centered machine learning. So see the one that speaks to you the most and just dive in, interesting yourself. The second one is interdisciplinary work, interdisciplinary work, interdisciplinary work. You don't expect to gain literacy on both machine learning and HCI or whatever other discipline you want. You bring your expertise, have enough literacy to communicate with other experts, and you have to work as teams. That's my short and quick advice. Happy to talk about offline about more about this.
Yep, Stevie?
So I just recently went on the and had to deal with similar problems about making sure that I could communicate what it meant to do human-centered machine learning. Staying in your lane and having your domain, or like I would say subfield of computer science, that's your primary contribution area, can help people make more sense of your work. But the other thing that's really important is to stick to your guns and defend your lane. So it's easy for somebody to see your work and slide it into other fields. So is it interactable? Is this also explainable? And at that point, you're I don't want to say losing control of your story, but it can be easy to make it feel like your work is watered down. And so I want to encourage you, if you're working in this space, it can be tempting to say, I do lots of things, defend your lane. You are part of your field, even if you have interest in other interdisciplinary places and you work with other people, you're a computer scientist, here you are. Tell the world that you are that.
Thank you. I think the session has kicked us out yet, so I think Bryan and Irene, you guys have time to give any tips if you want to.
Sure, and I probably represent more so the industry perspective than academia. I can speak for that, but I would say, it's a huge field. So you don't only have to contribute if you're a machine learning PhD student, right? I mean, this field employs writers, educators, people in policy, lawyers that are specialized in machine learning issues. So I would also say, if there are people here that are coming from different backgrounds or want to slightly go in a different route and not just be an engineer or a researcher, there is room for you in this industry, and we need all sorts of people.
Oh, now you expect something deep from me. I feel like we're at time, so I don't want to hold people over. I think what everyone else said was pretty cool, so I'll leave it there.
All right. Well, thanks, Bryan, Stevie, Irene, and Gonzalo, and thanks to all of our viewers here. this was a great panel. I am blown away by all the research that you all are doing, and I expect great things from all of you. So thank you very much. Hope to connect with everyone.
Yeah, thanks for moderating.
Yeah.
Yeah, no
Yeah,
problem.
thanks for meeting everybody, and feel free to contact us offline. I think we're easy to find.
Absolutely.
Great. All right, thanks. See you all soon, hopefully.